Out of all the emails a secretary receives, she receives one from her boss 33% of the time. She also randomly drives to work instead of walking 98% of the time. So what is the probability that she opens an email from her boss and at random and drives to work? If you need to find the probability of two things happening, like opening an email from a boss and driving to work, then you can find the probability that both of them happen by multiplying the probability that the first happens on its own times the probability that the second happens on its own. So the probability that we open an email from our boss is 0.33. The probability that we drive to work instead of walking is 0.98. So if you multiply those two together, that's the probability that we drove to work and we opened an email from our boss. So 0.3234, I think it was. Mike has a dresser with 3 tan pants, 5 jeans, 2 black pants, 3 gray. Holy cow, there's a lot of stuff going on here. If he randomly chooses a pair of pants and shoes, what is the probability that both are black? Randomly chooses a pair of pants and randomly chooses a pair of shoes. Those are our two events. So let's find each event separately, just like we saw before. To find out the probability of both of them, A and B, then we need to know the probability of just A and multiply it to the probability of just B. So the probability that we pick, it's specifically black pants, not just pants in general. Wow. Black shoes. Okay, the probability of A, probability of picking black pants, there's 2 black pants out of a total of 3, 8, 10, 13. There's 13 total pants. And the probability of B, of picking black shoes, there's 3 black shoes out of a total of 2, plus 3 makes 5, plus 2 makes 7. So that's the probability of picking black pants, because there's 2 out of 13 are black. And that's the probability of picking black shoes. There's 3 out of 7 shoes that are black. So to find the probability of having both of them happen, 2 over 13 gets multiplied to 3 over 7. You multiply the two probabilities to find out the probability of both of them. So if you multiply straight across the top, 2 times 3 makes 6, and then straight across the bottom, get 6 out of 91. Exact fraction, so that's exact because there wasn't any cross simplification we could do. 6 out of 91 is our fraction. So if we're asked the probability of getting a black card or a 3, the word or means we need to use that union formula we talked about in the last problem. It's the probability of A, of getting a black card, plus the probability of B, getting a 3, and then we have to subtract the probability of A and B. And there's a reason for that. If you draw a Venn diagram, we haven't really done Venn diagrams yet, but the probability of A plus the probability, we have to subtract the probability of A and B because this is where the two circles, where A and B meet up with each other, where the events A and B cross. So look, this has the probability of A and B in it. This has the probability of A and B in it. So it's like you're counting this twice. You've got to subtract one of them out of them. So that's just kind of the theory behind why we do that. But the probability of getting a black card, there's 26 out of 52, which is 1 over 1/2. There's a 1/2 chance of getting a black card. And the probability of getting a 3, there's 4 of those out of a deck of 52. So that's 1 over 13. And now what's the probability of A and B? Well, that's the probability of getting both of them, A and B. And we're going to assume that we replace the cards after. It doesn't really specify that. So basically, since drawing the two are independent, one event doesn't affect the other, we're going to assume, then the probability of having both of them happen is found by multiplying these two. So 1 times 1 is 1, 2 times 3 is 26, so we have to subtract 1 out of 26. And now it's just fraction work. Now we need common denominators. So this is 13 out of 26 plus 2 out of 26 minus 1 out of 26. So that's going to be 15. That's 14 out of 26, or if you simplify, that's 7 out of 13.